Hello everybody, I am Biswajit Mandal, lecturer in Electrical Engineering, Mayurbhanj School of Engineering. So today I have brought for you the topics from SGPD, that is circuit breaker. ताले आमे सर्किट ब्रेकर को जो जीवा तार सर्किट ब्रेकर कहले कौन बुझा जीवो ताको प्रथमे देखिया. तो as per the definition, a circuit breaker is the switching and current interrupting devices, that is mechanical devices which is used for switching as well as current interrupting. So according to the definition, that is the circuit breaker is a switching and current interrupting mechanical device which closes and opens its contacts, thus closing and opening the circuits. So this is called circuit breaker. ताले इटा को आमे सर्किट ब्रेकर कहबा. आ सर्किट ब्रेकर कोन आमे जानि पारले ताले एटा गोटे करंट इंटरप्टिंग आ स्विचिंग डिवाइस. तो तार ऑपरेटिंग मेकानिज्म कोन रहउची ताको नेक्स्ट आमे जीवा. तो ऑपरेटिंग मेकानिज्म को बुझिबा आगु तार डिफरेंट पार्ट्स जो रहिछि ताको आमे ऑब्जर्व करिवा. तो कोन कोन पार्ट्स रहिछि आपण देखिबे. प्रथमे रहिछि गोटे बस बार रहिछि, सेथरो सर्किट ब्रेकर को कनेक्शन आछि. पुणी सही लाइन रे तमरो सीटी रहिछि, सीटी रो प्राइमरी आ तार सेकेंडरी रे रहिछि रिले कॉइल. आ से रिले कॉइल सहित गोटे आयरन प्लंजर कनेक्टेड हैछि. आ से आयरन प्लंजर जतेबेले दुईटा स्टेशनरी कॉन्टैक्ट्स रिले सहित अटैच हबो सेतेबेले ट्रिप सर्किट टा क्लोज हबो. ताले सेतेबेले क्लोज हला फलरे ट्रिप कॉइल टा एनर्जाइज्ड हबो. आ जेहेतु ट्रिप कॉइल एनर्जाइज्ड हो गला से मूविंग कॉन्टैक्ट को सेपरेट करिवो फिक्स्ड कॉन्टैक्ट रो, जा फलरे दुईटा भितरे गोटे आर्क डेवलप हबो. आ सही आर्क ड्यू टू आर्क एक्सटिंक्शन मेथड से क्लियर करिवो सर्किट ब्रेकर. तो एटा गला सर्किट ब्रेकर रो ऑपरेटिंग मेकानिज्म. तापरे आमे देखिया फंक्शन ऑफ द सर्किट ब्रेकर. ताले चारिटा फंक्शन रहउची सर्किट ब्रेकर रो. कोन कोन से गुडा को. तो प्रथमतः फर्स्ट ऑफ ऑल इट कैरीज फुल लोड करंट कंटिन्यूअसली विदाउट ओवरहीटिंग. हीटिंग न होई करी फुल लोड करंट को कैरी करिवा. ताले एटा फर्स्ट फंक्शन. नेक्स्ट सेमती इट ओपन्स एंड क्लोजेस द सर्किट ऑन नो लोड. नो लोड कंडीशन रे सर्किट को क्लोज और ओपन करे. सो इफ यू गो टू द थर्ड फंक्शन, इट मेक्स एंड ब्रेक्स नॉर्मल ऑपरेटिंग करंट. नॉर्मल ऑपरेटिंग करंट रे सर्किट ब्रेकर को क्लोज करे एवं सही टाइम रे मध्य नॉर्मल करंट को भी से ब्रेक करि पारे. तनो इट मेक्स एंड ब्रेक्स नॉर्मल ऑपरेटिंग करंट. देन द फोर्थ फंक्शन, इट मेक्स एंड ब्रेक्स शॉर्ट सर्किट करंट. दैट मीन्स अंडर शॉर्ट सर्किट कंडीशन it closes its contacts and also the short circuit condition it breaks the contacts, that is its contacts gets open. Next, arcing phenomena. So arcing phenomena, in this phenomena the arc which is developed between these two contacts, these are called current carrying contacts, that is fixed contact and moving contacts. So in between these two an arc is developed. So how this arc develops we will discuss, but before that, what is arcing phenomena? It is the column of ionized gas. Column of ionized gas that is formed when some electrons are detached from the atoms of that gas, and it is in this way we can define it as a arc. Thereafter the process of arc extinction. So if we go to the arc extinction process, that means arc टाको केमती लिभा जीवो. So there are two methods. We'll first discuss about field emission method, then thermoionic emission method. So this after that we'll go to the fluids. So first of all come to the fluid emission, field emission, that is field emission. So in this field emission we observe that when the two contacts, that is moving contacts, when get separated from the fixed contact, thereby the arc area, contact area get reduced, and at that time due to the reduced in area we get that high resistance because R is equal to rho L by A. So if we get reduced, then area is reduced, but at that time there is increase in the resistance, but this resistance is very small, and due to the fault current which is of large magnitude, there is an voltage gradient of 10 to the power 6 volt per cm. So that is why it emits electrons from one plate to the another. So next we will discuss about thermoionic emission. Now let us move to the thermoionic emission. This is the second method by which we can know how the arc is formed. So first of all we have seen the field emission. Likewise in this thermoionic emission, if we observe that the two contacts, that is fixed contact and moving contacts, so that the moving contacts during fault condition when gets separated, at that time I have told in the field emission that the contact area get reduced. Due to reduction in contact area, that is resistance is increased, but due to less resistance increase, there is increase in the current density. Due to this increase in the current density, there is increase in the temperature, which dislodges some of the electrons from cathode to anode surface, and this process is known as thermoionic emission. So either two of this process or combinedly these two process makes the formation of arc. So we have discussed the process of arc formation. Next, medium of fluid used in the circuit breaker. So inside the circuit breaker there are two current carrying contacts, fixed contact and moving contacts, and surrounding it there is a fluid. So there are 5 types of fluids: air at atmospheric pressure, compressed air, then oil producing hydrogen for arc extinction, ultra high vacuum, and sulfur hexafluoride. Next, the properties of fluid medium. So what are the properties? So there are 3 properties. The fluid medium should have high dielectric strength, high non-inflammability, high thermal stability. तामने तमर हाई डाइलेक्ट्रिक स्ट्रेंथ भी रही से फ्लुइड नॉन इनफ्लेमेबिलिटी माने दहनीय नुहे है तापर हाई थर्माल स्टेबिलिटी माने टेम्परेचर को विथस्टैंड करिवार कैपेबिलिटी थिबो ताले 3टा गुण बा 3 प्रॉपर्टीज शुड बी देयर ऑफ फ्लुइड मीडियम. नेक्स्ट, फंक्शन ऑफ दिस फ्लुइड्स. So if we go to the function of the fluids, then we will observe that there are 2 functions. First of all, extinction of this arc or the arc extinguishes. Then second is to provide the insulation between contacts and arc. So this is very clear to everyone that these 2 functions are the functions of the fluid used inside the circuit breaker. Then next, factors affecting the maintenance of arc. If we go to the maintenance of arc, how the arc is maintained between these 2 contacts, then we will observe the following 2 things. That is, if the potential difference is there between these 2 contacts, then the arc will persist. Similarly, if the ionized particles are present between these 2 contacts, then also there is maintenance of this arc. So due to this, these 2 factors are responsible for maintaining the arc. So but our requirement is what? That we want to extinguish the arc. We want to extinguish the arc. That is why either we can decrease the potential difference between these 2 contacts, or either we can sweep away the ionized particles between these 2 contacts. So these are the 2 things on which the maintenance of arc depends. So thereafter we go to the conduction of arc, which is proportional to 3 things: number of electrons per unit volume present, square of the diameter of the arc, and reciprocal of the length. So reciprocal of the length is the major things, so which we cannot increase the length due to high voltage circuit breaker. Similarly, if we increase the square of the diameter of the arc, then the arc will persist. Similarly, if there is number of electrons per unit volume is more, then also it is persist, the arc will persist. So these are the 3 factors on which conduction of arc depends. Next, Methods of arc extinction. So there are two methods of arc extinction, generally high resistance method as well as low resistance method. So first of all come to the high resistance method.
Sir, next जो बोले ना, हाँ, next पकड़े काटूँगा. Next we will
discuss about the method of arc extinction. अच्छा अच्छा. So next we will discuss about the method of arc extinction.
बुझलो? ए, बुझलो? ये काटो ना? এটা নাকি সেটি জুড়ে দেব। হবে তো? ওকে। जीवासा नेक्स्ट पार्ट है 1 2 3.
So let us discuss about the high resistance method. So in this method the arc resistance is gradually increased so that the heat is not sufficient to maintain the arc and current value is also reduced. That is why arc is extinguished. So this is the main things which is done in case of high resistance method of arc extinction. But the trouble here is that during this high resistance method of arc extinction, due to resistive nature of this arc, the large amount of energy is generated inside the circuit breaker. So the circuit breaker should be designed in such a way to persist or to withstand such mechanical shock. That is why this type of arc extinction method is applied in DC circuit breakers as well as AC circuit air brake type AC circuit breaker of low capacity. Next, this is the high resistance method of arc extinction is possible by 4 methods, that is cooling of arc, lengthening of arc, reducing the cross sectional of the arc and splitting of this arc. So these are the 4 methods by which we can get the high resistance method of arc extinction. So when we cool the arc, at that time the ionized particles are recombined so that the dielectric strength between these two plates or between the fixed and moving contacts get increased, and as a result arc is extinguished. Similarly, if the length of this arc is increased, then the resistance will increase. But if we reduce this length, then the resistance will decrease. So by reducing the length of this arc, we can decrease. Similarly, reducing the cross-sectional area of this arc. If we reduce the cross-sectional area of this arc, then also resistance is increased. Then the splitting of this arc. By splitting of this arc, if the arc is splitted into separate arcs, then its length is increased and it is get cooled. That is why arc is extinguished. Next, low resistance method of arc extinction. Arc resistance is kept low until current 0 is reached, and thereafter the current interruption takes place at natural current 0 and arc is not allowed to rise again. This is achieved by length of this arc, increasing the length of this arc, increasing pressure in the vicinity of the arc, cooling of this arc and blast effect. Okay. So next, this can be possible or this can be explained by energy balance theory, which is nothing but if the rate of dissipation of energy is more than that of the rate of generation of energy, then the arc will be extinguished. Similarly, recovery rate theory, another theory to explain this low resistance method, that is if the rate of building of dielectric strength is more than that of the rate of development of voltage stress, then the arc will be extinguished. ताले वर्तमान देखिबा क्लासिफिकेशन ऑफ सर्किट ब्रेकर. ताले सर्किट ब्रेकर रा करंट को नै कि जदि हमें क्लासिफाई करबा ताले एसी टाइप सर्किट ब्रेकर और डीसी टाइप सर्किट ब्रेकर रहउची. सिमिलरली जदि हमें रेटेड वोल्टेज को कंसीडर करबा ताले लो वोल्टेज सर्किट ब्रेकर और हाई वोल्टेज सर्किट ब्रेकर भी रहउची. तापर सेमती हमें जदि हाई वोल्टेज सर्किट ब्रेकर पुणी क्लासिफाइड हेची ऑयल सर्किट ब्रेकर और ऑयल लेस सर्किट ब्रेकर. ऑयल लेस सर्किट ब्रेकर गुड़ाकर टाइप्स गुड़ाक जब आम कनसीडर करवा ताले आम पाइबा वाटर टाइप सर्किट ब्रेकर, एयर ब्रेक सर्किट ब्रेकर, एयर ब्लास्ट सर्किट ब्रेकर, सल्फर हेक्साफ्लोराइड सर्किट ब्रेकर एंड वैक्यूम सर्किट ब्रेकर. ताले आम वर्तमान जीवा SF6 सर्किट ब्रेकर. ताले गोटे सर्किट ब्रेकर को आम देखा केमती तार ऑपरेशन होउछ. ताले जदि आम कंस्ट्रक्शन को जीवा बा अरेंजमेंट को जीवा SF6 टाइप बा सल्फर हेक्साफ्लोराइड टाइप सर्किट ब्रेकर को ताले आम मार्क करवा एठे तुम फिक्स्ड कंटाक्ट रही जो थे तुम आर्किंग हॉर्न रोची आ से तार टिप्स गुड़ाक फिक्स्ड कंटाक्ट गोटे कॉपर टंगस्टेन कोटिंग दि जाऊँगी हाई रेजिस्टेंस है तापर मूविंग कंटाक्ट्स टिप गुड़ा कोटिंग दि जाइए कॉपर टंगस्टेन कोटिंग से मूविंग कंटाक्ट्स साइड को गोटे जदि आम देखा ताल गोटे ओपनिंग अच्छी सेटा एक्सहाउस्ट गैस बाहर लगी आ मूविंग कंटाक्ट जो गोटे सिंक्रोनाइज मेकानिज्म द्वारा SF6 भाल्व सहित कनेक्टेड होता रिजर्वर सहित कनेक्टेड तो एतिकी गला कंस्ट्रक्शन जब तार ऑपरेशन को आम आसवा ताले आम ऑब्जर्व करवा जिते नॉर्मल कंडीशन ऑफ ऑपरेशन थाए से फिक्स्ड और मूविंग कंटाक्ट गोटे क्लोज एसोसिएशन रे थांती जिते फॉल्ट हो जाए से मूविंग कंटाक्ट सेपरेट हो जाए फिक्स्ड कंटाक्ट रू भितर गोटे आर्कटा डेवलप हुए ड्यू टू मूवमेंट ऑफ दिस मूविंग कंटाक्ट दैट इज ओपनिंग ऑफ दिस valve of SF6 gas reservoir. As a result, SF6 gas entered into the arcing chamber and within that chamber it absorbs the electrons. That is why immobile electrons are produced, which creates the large dielectric strength. That is why arc is extinguished. Next, we will go to the axial blast type air blast circuit breaker. In this type of circuit breaker, two types of current carrying contacts are there, that is fixed contact and moving contacts, which are under normal condition are placed against each other with spring pressure, that is in close contact with each other, and the arcing chamber is connected with the air reservoir through an air valve. Similarly, if this type of circuit breaker has a series isolator switch for the sufficient clearance after the arc extinction for normal voltage. So its operation, if we come to its operation, then when fault occurs at that time tipping impulse causes the air valve to open and thereafter the air is forcefully blasted into this arcing zone, so that it moves away the fixed moving contacts. It moves away the moving contacts from the fixed contact, thereby an arc is developed. And since this constant flow of air is blasted into this arcing zone, gradually the diameter of the arc reduced and finally the ionized particles are swept away from these two contacts, between these two contacts, and as a result the dielectric strength increases and the arc is extinguished. So this is all about the circuit breaker we have discussed. So generally we have discussed what is circuit breaker, what is its function, how it operates, arcing phenomenon, how it develops, and then the method of arc extinction, then classification of circuit breakers also we have discussed, and finally the operation of SF6 type circuit breaker and axial type air blast circuit breaker. So this concludes our circuit breaker topic, and hope you have enjoyed it, and thank you for watching.